Hello and Assalamualaikum to all panels. My name is Syahmirul bin Abdul Johar. Today, I would like to present about my final year project proposal presentation. This project was supervised by Sir Ramlan Kasiran and co-supervisor Sir Tajuddin Mat Jahid. My title for this final year project is F1 in School Wheel Assembly Design Alpha. Now let's go to the project summary. For the project summary, F1 in School Car is the competition for the students to collaborate, design, analyze, manufacture, test, and then race miniature compressed air powered cars made from F1 model block. The research will determine the best wheel design, size, and assembly process between wheel and its other components on the F1 in School Car miniature. Based on the analysis of the formulation moment of inertia and resistive force of rolling friction, all the important criteria in designing the best wheel can be achieved. The targeted time for the miniature to reach the finishing line is 0.98 seconds. The polylactic acid will be used in designing the wheel as it has a good mechanical properties such as high hardness that can hold the total load of the car from static condition to dynamic condition. Now let's go to the introduction and background. This study will provide an overview and analysis of wheel assembly to achieve the objective of creating a car that can travel to the finishing line in the quickest time. According to the rules and regulations, a wheel's minimum width is 12 mm for the front wheel and 15 mm for the rear, and its permitted diameter range from 28 mm to 34 mm. The ideal wheel size and material for the car's performance will be determined by this report. The wheel will be assembled to the shaft and lock the shaft and wheel by using the stopper. The moment of inertia must be in the smallest value possible. By referring to the formulation, the mass and the radius of the wheel must be in the smallest value but enough to withstand the total load of the car. Other than that, the resistive force of rolling friction is the main concern in the research. Based on the formulation, the coefficient of friction must be in the smallest value so that the resistive force will become small as they are related to each other. In the literature review, there are 7 aspects were covered in the report, but 3 main aspects that need to be highlighted are wheel size, wheel mass, and moment of inertia. For the wheel size, larger wheels often make a vehicle more stable, especially when navigating potholes and rougher terrain. However, for this case of study, the bigger size will give disadvantage to the performance of the car, where the weight and the size of the wheel will produce bigger mass moments of inertia. Then, wheel mass. According to the second law of Newton, the force acting on an object is inversely equal to its mass times its acceleration. Based on how the wheel structure distributes their mass, angular velocity can be considerably impacted. In comparison to rims or lip mass, the center mass close to the rim has an excessively reduced rotating inertia. Lastly, moment of inertia. The moment of inertia must be in the smallest value possible. By referring to the formulation, the mass and the radius of the wheel must be in the smallest value, but enough to withstand the total load of the car. The acceleration may be determined with accuracy by measuring the duration and length of the mass drop. Next, problem statement and objectives. Based on the extensive literature review, the problem statement is to determine the dimension, design, and material for the F1 in school car wheel. Other than that, is to successfully assemble the wheel and the shaft attached to the body of the F1 in school car. On the other hand, the main objective of this final year project is to successfully design, analyze, and construct a fully functional wheel for the F1 in school car that will help the car to travel along the track system in the shortest time. Now we go to the scope and the limitation. For the scope, the research study seeks to determine the correct and suitable design of the wheel and the assembly design between the wheel and the shaft attached to the body of F1 in school car, so that the car can travel along the track system while withstand the load of the car. For the limitation, the research was conducted in a short period to analyze the wheel's formula and design. Besides, the low availability of the article on the website leads to difficulty in analysis and comparison purposes. Therefore, a comparison for the article on the same topic cannot be made. No simulation were done for the analysis purpose in designing the wheel of F1 in school car. Next, we go for the methodology. This is the flowchart for my final year project. The first one is start. Next is the literature review based on the selected article. Next is the define problem of the project. Then, determination of the related formula. Next is establish PDS. Next is the figure out the scope and the limitation. And next one is we go to the evaluation on the selection formula. Last is the summary and conclusion before we met the end of the flowchart. The methodology for the analysis purposes is by using a formula and relate the formula with the calculation. By using the formula, the wheel size and dimension can be determined for analysis. The formula and analysis for this project is moment of inertia and resistive force of rolling friction. So let's go to the Gantt chart. This is my project planning. The green one is the expected planning, while the yellow one is actual. As can be seen from the Gantt chart, most of the activities were planned and done according to the timeline except for the information research, which has done in week 10, whereas the planned one should have been done in week 8. However, the overall project was successfully done within the given time. The last one of my presentation is the expected result. Based on the analysis is to obtain a complete calculation on the rolling coefficient, mass moment of inertia, and frictional moment. Based on the calculation and analysis, the size of the wheel and wheel assembly design can be constructed. Besides, the size of the wheel that can withstand the load of the F1 car and achieving the target to reach the finishing line fastest time as possible. That's all for the final year project presentation from me. Thank you.